Dear students, now we will see the next part of current electricity. Before this, we already learned about some concept about this current electricity in first part of this lesson. In this part, we have to learn about Ohm's law and parallel and series resistance. First, we will see about Ohm's law. What is Ohm's law? If the physical state of a conductor remains constant, the current R flowing through it is directly proportional to the potential difference between its two ends. If the physical state of a conductor remains constant, the current I flowing through it is directly proportional to the potential difference V between its two ends, means R is directly proportional to V. Here, physical state of a conductor means its length, area of cross section, temperature and material it is made up of. So, this is the final formula for Ohm's law, R equal to V upon I. Please, then we will see about electric circuit. This is the electric circuit for Ohm's law. A continuous path of electric current through conducting wires connected to two ends of a cell and other resistances is called an electric circuit. Here, this is the electric circuit in which ammeter is connected. An ammeter is used to measure the current. Here, voltmeter is also connected, which is used for measuring the potential difference. And here you will see the resistance. This is conducting wire, conductor, electric cells. Also, the keys are here. So this is the electric circuit. Some symbols for component of electric circuit and their uses. We have to see a component. Here is a regular picture of that component. This is a symbol and uses. The electric cell will look like this. You have to draw the symbol like this. Electric cell is used to apply a potential difference between two ends of the conductor. Then battery, like this we have to join the cells. Symbol is like this and used to apply a larger potential difference between two ends of the conductor. Then open tap key or plug key, you have to show like this to stop the flow of current flowing in a circuit by disconnecting two ends of the wire. Then symbols for components of the electric circuit and their uses, in which another component is a closed tab key or plug key. We are showing like this. It is used to start the flow of current in a circuit by connecting two ends of wire. Then connecting wires, we can draw like this to connect various components in the circuit. These connecting wires are used. Then crossing wires, to show like this crossing wires and used to show wires which cross but are not connected. Then light bulb, to test the flow of electricity. lighted current is flowing, unlighted current is not flowing. This is unlighted, this is lighted. In this there is a flowing of current, here there is no flowing of current. Next component is resistance. Picture of resistance is like this, but we are drawing the symbol like this. To control the flow of current in the circuit, we are using this resistance. Then variable resistance, symbol of variable resistance is like this, used to change the resistance as required and hereby control the current. Then ammeter, we draw like this. It is used to measure the current flowing in the circuit. Then voltmeter, symbol is like this and used to measure the potential difference between 2 points in the circuit. Then we will see about conductors and insulator. What is conductor? Those substances which have very low resistance are called conductors. Current can flow easily through such material. For example, copper wire, aluminum, these some metals. Insulator, those substances which have extremely high resistance and through which current cannot flow are called insulator. For example, wood, plastic, glass, etc. Experimental proof of Ohm's law. In this experiment, material we have to use that 4 cells of 1.5 volt each, ammeter, voltmeter, conducting wires, nichrome wire, plug. You have to make observation chart like this, in which number of cells used you have to write here, then current which is measured with the help of ammeter, you have to write the reading of that ammeter. We can convert that current into ampere from microampere to ampere, and in this column you have to write the potential difference which is in volt, we measured with the help of this voltmeter, and in this column we have to calculate V upon I, means this is the voltage upon current current here, V upon I we have to take here. We will see that every time this V upon I will get a same answer. Then resistance in series. This is the R1, R2 and R3, three resistance. We are connected in a same lane. Resistors are connected to that, they follow one after one in a single lane. These resistors are said to be connected in series, one by one in series. Also there is a connection of plug key, then ampere, battery, and here voltmeter. Parallel connection of voltmeter and in series connection of ammeter. In such an arrangement, the same current flows through each resistance. The current flows from here, that will continuously goes in each of the resistance from here to here. The value of current is I and the potential difference between C and D is V. From here to here, if you measure the potential difference, it will V, and current we are passing through these resistance is I. The three resistors R1, R2 and R3 are connected in series in the circuit. If you V1, V2, if V1, V2 and V3 are the potential difference of the every resistors. Here, if you measure the potential difference between these 2 points of the R1, that will be V1. Here, if you connected voltmeter, will get the potential difference between 2 points, that is V2. And here we will get the potential difference between these 2 points, means during R3. That's why V equal to V1 plus V2 plus V3. Suppose this is equation first. If Rs is resistance in series, that is effective resistance in series between C and D, then according to Ohm's law, V equal to IRS. Then V1 equal to IR1, V2 equal to IR2 and V3 equal to IR3. If you substitute all these in equation 1, we will get IRS equal to IR1 plus IR2 plus IR3. Then RS equal to R1 plus R2 plus R3. If n resistors are connected in series, then we will get like this: Rs equal to R1 plus R2 plus R3 plus dot 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 plus Rn. So this is the equation of resistance in series, effective resistance, equation of effective resistance in series, that is Rs equal to R1 plus R2 plus R3. If resistors are connected in series, the same current flows through each resistor. The effective resistance of the resistors is equal to the sum of their individual resistance. The potential difference between the two extremes of the arrangement is equal to the sum of the potential difference across the individual resistors. The effective resistance is larger than each of the individual resistance, and this arrangement is used to increase the resistance in the circuit. If you want to increase the resistance in circuit, you have to arrange the resistance in series. The resistance of some conductors becomes nearly zero if the temperature is decreased up to certain values close to 0 Kelvin. Such conductors are called superconductor. Some conductors do not obey the Ohm's law. Such conductors are called non-ohmic conductors. When resistors are connected in series, they are connected one after another. If any one of them does not function, the circuit breaks and there is no flow of electricity. If two bulbs are connected in series, they will both give less light than if they had been connected individually. If three bulbs are connected in series, their light output will decrease further. Then we will see about resistors in parallel. This is a diagram of resistance in parallel. R1, R2 and R3. These are the three resistors we are connected in these 2 points parallelly. Also here a voltmeter is connected parallel to these resistance, and here ammeter is connected in series in this circuit. This is a battery and this is plug key. Resistors are said to be connected in parallel when their ends are connected at both sides as shown in this figure. Both sides, every end of these resistors are connected in these both points C and D. In this figure, three resistors R1, R2 and R3 are connected in parallel between points C and D. V is the potential difference between C and D. Let us I1, I2 and R3 be the currents flowing through R1, R2 and R3 respectively. Then the total current flowing through the circuit is I equal to I1 plus I2 plus I3. Suppose this is the equation first. Then effective resistance Rp equal to you have to calculate the effective resistance of these resistance which are connected in parallel. According to Ohm's law, I equal to V upon Rp. Similarly, I1 equal to V upon R1, I2 equal to V upon R2 and I3 equal to V upon R3. If you substitute these values in equation first, means here instead of I equal to I1, I2, I3, if you substitute these value, we will get V upon Rp equal to V upon R1 upon plus V upon R2 plus V upon R3. Finally, we will get 1 upon Rp equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is the equation of effective resistance which are connected in parallel. If n resistance are connected in parallel, we will get 1 upon Rp equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus dot 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 plus 1 upon Rn. Even if any one of the several bulbs connected in parallel becomes non-functional because of some damage to its filament, the circuit does not break as the current flows through the other path and the rest of the bulbs light up. When several bulbs are connected in parallel, they emit the same amount of light as when they are connected individually in the circuit, while bulbs connected in series emit less light than when connected individually. Remember, if the number of resistors are connected in parallel, the universe of effective resistance is equal to sum of the universe of individual resistors. The current flowing through an individual resistor is proportional to the universe of its resistance, and the total current flowing through the circuit is the sum of the current flowing through individual resistors. The potential difference across the end of all resistors is the same. The effective resistance of resistor connected in parallel is less than the least resistance of the individual resistors, and this arrangement is used to reduce the resistance in circuit. If you want to reduce the resistance in circuit, you have to arrange the resistors in parallel. This is the some electrical appliances connected in a circuit in our home. Domestic electrical connections. The electricity in homes is brought through the main conducting cable either from the electric pole or from underground cables. Usually There are three wires in the cable. One is called the live wire, which brings in the current. It has a red or brown insulation. The other wire is neutral, through which the current returns. It is blue or black. In India, the voltage difference between the live and neutral wire is about 220 volt. Both these wires are connected to the electric meter through a fuse from main switch. They are connected to all the conducting wires inside the home so as to provide electricity to every room. In each separate circuit, various electrical appliances are connected between the live and neutral wires. The different appliances are connected in parallel and potential difference across every appliance is the same. The third wire is called the earth wire and is of yellow or green color. This is connected to a metal plate buried deep underground near the house and is for safety purpose. Then we'll about fuse wire. Fuse wire is used to protect domestic appliances. It is made of a mixture of substance and has a specific melting point. It is connected in series to the electric appliances. If for some reason the current in the circuit increases excessively, the fuse wire gets heated and melt. The circuit gets broken and the flow of current stops, thus protecting the appliances. This wire is fitted in groove in a body of porcelain like non-conductive material. For domestic use, fuse wires with upper limits of 1 ampere, 2 ampere, 3 ampere, 4 ampere, 5 ampere and 10 amperes are used. These are the diagrams of fuses, that is ceramic fuse and this is cartridge fuse. We will see about precautions to be taken while using electricity. Electric switches and sockets should be fitted at a height at which small children cannot reach and put pins or nails inside. Pull a plug, pull a wire should not be pulled while removing a plug from its socket. Before cleaning an electric appliance, it should be switched off and its plug removed from the socket. One's hands should be dry while handling an electrical appliances, and as far as possible one should use footwear with rubber soles. As rubber is an insulator, it prevents the current from flowing through our body, thereby protecting it. If a person gets an electrical shock, you should not touch that person. You should switch off the main switch, and if the switch is too far or you do not know where it is, then you should remove the plug from the socket if possible. If not, then you should use a wooden pole to push the person away from the electric wire. So dear students, you have to remember all these things while using the electricity. Now we have to read the lesson which is in textbooks and solve the exercise. If you have any doubts, you have to call me on this number or you can write your questions with the help of WhatsApp. Thank you.